So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you all can see on the screen, or you are well aware, my subject is physics. We are in class 6. Today we are going to start a new chapter, the chapter number 4, work, power and energy. So today we are entering into the session number 1. So far we completed 3 chapters in as per the material, and entering into the 4th chapter, which is deal with the 3 important terms, physical quantities, work, power and energy, right? So this is the chapter number 4. Okay, so these are the 3 different terms which are connected to each other: work, energy and power. All these are connected to the force which we discussed in the last chapter, that is laws of motion. So it's a continuation where we started with the units, then we came to the kinematics, then we come to the laws of motion, next come to the work, power and energy, which are the continuation of chapters from all classes from 6th to 10th. Okay, so there is an extension of the concept. So today we are going to start the new chapter, the chapter number 4, where we are going to learn about 3 important physical quantities and with various examples, that is how they are applicable in our day-to-day life. Applications of work in our day-to-day life, application of energy in our day-to-day life, application of power in our day-to-day life, right? With very good number of examples we'll discuss. So when you move forward, so definitely is the work done. So generally when you do any work, we'll do that. My work is done. The simple symbol for work done. A simple symbol to know about the work, right? Now this is our chapter. You can turn on the page number 60. Today we are starting the page number 60 with chapter number 4, work, energy and power, right? Then we'll see what is work. So work done by a force. So when there is no force, see, for doing work, there should be force and there should be, body should be displacement, right? So whenever you are applying force on any object, if body displaces, then you can say work is done. Then we'll discuss about even types of works also. There is a positive work, there is a negative work, there is a zero work. So many types are there, right? So first let us know what is the relationship between the force and displacement to define the work. The word work has many different meanings. The Ramayana is a great work of Valmiki. Because of Valmiki wrote the book, we came about Ramayana. That is a good work. We'll say, if you do anything good in class, your teacher will say good work. Not only in marks, different cases. So the word work can be applicable in many places. So it is different in physics. In physics it is different. But generally see, the Ramayana is a good, great work of Valmiki. The machine is working in order. It's also work only. When a machine is working properly, we can say it is in order or it is having some problem. There are large number of worked out problems in this book. Worked out problems. So many problems are solved, problems are there. Worked out problems. This is also a word work comes here. These are the just some way to use the word work. So any of these conditions, you can use the word work. Good work done by the Valmiki in writing the Ramayana. The machine is working. The working condition of machine is good. There's a large number of workload problems in the book, physics. Like that, anywhere, there are so many ways you can use the word work in our regular life. But when you come to the physics, it will be different. Different meaning is there. So in physics, however, it has special meaning. It represents a physical quantity defined in the special way, which we shall describe below. So it explains the word physics with the help of the physical quantities, that is force and displacement. Okay, when force acts on an object, suppose an object is there, a wooden block, right? Force on this act, right? This is a block. Force acting on this, right? And object moves. So object comes from here to, it moves for some distance. Object moves. We can say that force has done some work on object. That is said to be a work done by a force. Either you want to pull the chair, or you want to push the table, or you want to open the door, or you want to close the door. All these are works only. But there should be a force applied and body should displace. If body is not moving, we cannot say work is done. Body should move. Then only you can say some work is done. Okay. So we can say that force has done the work. Work is said to be done, very important. Work is said to be done when a force applied on a body displaces the body through a certain distance in the direction of force. You are applying force heavy on heavy body. Heavy container is there. You want to move that. You are applying force, but you are able to move. Then you can say there is no work is done. Even though you are applying force, if body does not move, we can say work is not done. But whenever force is applied and body moves in the direction of force, we can say that work is done. So work is said to be done when a body displaces along the direction of force. Very, very important. You can write this part. Right? Write as a first point. Very important. Work is said to be done when a force is applied. Right? Work is said to be done when force is applied on a body, displaces the body through a certain distance in the direction of force. Right? Suppose you want to move your table towards you, or you want to move away from you. Anything. We need to apply the force, then only body displaces. We can say work is done. If body not displaces, no work is done. As per physics. Okay, you have seen already. The word work can be used in many ways. Even though you are doing any work, any appreciations for anybody, will say that done good work. You have done great job. You have done good job. Good work. What is that meaning? That is different work. That terminology is different, but when it comes to physics, it is deal with some physical quantities are like force and displacement. Clear? Right. Force and it is related to force and displacement. Now come. When you come here, work done by a force. Now come to physics. We'll come to physics point of view. Let us constant force F be applied on a body such that it makes an angle theta. So this is different case you see. Actually, the work done is equal to force into displacement. Very, very important formula. Force into, that is, W is equal to F into S. The formula for the work. So, you know, F is measured in Newton and S is measured in meter. Meter or centimeter. That is, Newton meter is the unit, or it's also called known as Newton meter or joule. Joule or erg. Joule is in SI system, erg is in CGS system. Right? W is equal to force into displacement. You can of the first point, you can write this. Second point. Right. Second point is note down as a force is equal to point number 2. The work done is equal to force into displacement, or W is equal to F into S. So W is equal to Newton into meter. Newton into meter, that is Nm or joule or erg. Right? So this is the physics definition of the. So a work is said to be done when a body applies a force applied on a body displaces the body through sustained distance in the direction of force, which is given by work is equal to force into displacement. That is equal W is equal to F dot S, or is measured in Newton meter or joule or erg. Clear? Right. So we move a little bit forward to know more about this work done. See here. So let us consider a force applied here, done such that it makes an angle theta, a special case, with horizontal and body displaced through a distance of S. Right, moving the S. Work done is equal to force into displacement, F into S. Thus, work done by a force is equal to the product of force and displacement. That is, work is said to be done along the direction of the applied force. So, whichever direction you are applying the force, in same direction, body is moving along the direction of force. So, SI unit is joule, that is Newton meter. W is equal to F into S. So, it is given by joule, or is named after the scientist. Right. So, before going for further, let me show you one video on work. Then we'll move to the next part. Right. Just see a video on work. After that, we'll move to the further explanation of the work.
On a typical day, you probably wake up, get dressed, eat breakfast, and head off to work. After you spend all day at your job, you go home, eat dinner, walk the dog, maybe watch some TV, and then go to bed. In this sense, work can be just about anything. Construction, typing on a keyboard, driving a bus, teaching a class, cooking food, treating patients, and so much more.
All these are works only.
But in physics, work is more specific. This is the displacement of an object due to force. How much work is done depends on the distance the object is moved. This makes it easy to put work into a solvable equation. Work equals force times distance. While this equation is fairly straightforward, there are three important things to note. First, the object must move over some distance in order for work to be done. Second, the force and the distance of movement must be in the same direction. And finally, the force must be constant.
Yes. So when you say work is done, these are the conditions. You can note down 3 conditions are there. So we can say work is done if the object moves over some distance. The force and distance of movement of the body should be in same direction. The force must be constant. In these 3 conditions, we can say that work is done. Okay, note down these 3 points after the 2 points.
Units we use for work are joules, named for
These are
James
named after the
Prescott joule.
scientist.
Though he is now known for his work in science, he actually preferred brewing beer until he realized how science could help him be a better brewer. The joule is a combination of both of the components on the right side of our work equation, force and distance. Quite simply, a joule is a Newton meter, and 1 joule of work is done when a force of 1 Newton is exerted over a distance of 1 meter. This amount of work is on par with lifting an apple over your head. I bet you didn't realize that.
Okay, so this is a simple video on work done by the, just simply explain about what is the work here. Now is measured in the joule. So joule is the unit for, so joule in MKS system as well as erg in the CGS system. So on conversion, if you see, we can see what is the relation between erg and joule. So 1 joule is equal to 10 power 7 ergs. Very important value. One joule in, suppose joule is nothing but SI system, is equal to 10 power 7 erg, which is in CGS system. We can derive this in higher classes. In simple, we can convert also, no issue, right? So this is about the work done on a system. So work is said to be done when a body displaces along the direction of force. So force should apply on the body and body should move some distance. Then only you can say that work is done. Right? Clear? Okay. So next, so work can be positive, work can be negative or zero, depending upon the direction of force and direction of motion. Suppose if force is applied on, say, one direction, say this is the body, we are applying force here, and this is F, and body is displacing in same direction. In same direction, moves to a distance of S. Then you can say this is a positive work. Right? Suppose when you are applying force in this direction, force acting on a body, vertical, and body is moving in the different direction. So we are applying force. For example, simple way, when you go to the garden, they'll use the machine to cut the grass, leveling the garden, right? So we'll apply the force in downward direction. But the roller will move horizontally. So there is some angle between the application of force and displacement. That kind of force is called, negative work. It's not in the direction of force. In this negative work, for example, if the force is acting horizontally, making an angle of 90 degrees with, so force is acting vertically and body is moving horizontally with an angle of 90 degrees, then work done is zero. Why? Because when angle comes into play, the work done formula is F into S cos theta, whereas cos 90 value is 0. Suppose the best example is when you go to the railway station or bus stop or aeroplane or flight, not there, this is only bus stop and railway station, you will hire one coolie to carry your luggage and keep it in the train. What you will do, will keep everything on a head, right? All the suitcases, some of them we hang here and he'll move. So what is happening? Force, the force is acting him in the vertically downward direction. He is moving horizontally on the platform. Right? The angle made by the force against the displacement is 90 degrees. See, don't think in physics terms of general. So you keep your back down, and if you say no, as per physics, W is equal to F into S cos theta, your angle between your force and it is 0. So the work done by you is 0. If you say 0 and I don't want to pay money, he won't accept. But physics point of view, that is correct. It is not application point of view. Whenever force makes an angle of 90 degrees with the direction of displacement, the work done is 0. So work done can be either positive or negative or even 0. Right? So Very important point this is. You can note this. The work done can be positive, negative, or zero. If you want, you can zoom in right also. Clear, all of you? Now, we'll see one by one. What is positive, what is negative, and all. Number one, work done. Work done by a force can be positive, negative, or zero. First one. Work done is positive when force acts in the direction of motion of the body. Right? Wherever you are applying force, the body displays in same direction, then body is said to be a work done is said to be a positive. See here, your car is here and magnet is here. Magnet, right? You are applying force with the magnet. Magnetic force is applied on car and pulls the cover towards itself. Then you can say that is a positive work. Work done by a force, work done by a force on a body is said to be positive work when the body is displaced in the direction of applied force. The body freely under the gravity, just pen, right? Gravity has positive work done by gravitational force. Correct? When you are dropping the body like this, it is moving towards the gravitational force and falling on the ground. So towards gravitational force is applied in the downward direction, body also moves in downward direction. So it is a positive work done. Correct? That is also comes under positive. Now, more are there. Clear? Now, when you come to second point. So first is here, when you apply force on any body, it moves towards the direction of force, positive force. Whenever a body is freely falling, it is coming towards the gravity is also a positive force. Now, case 2, if you see, work done is negative when the force acts opposite to the direction of motion. Suppose when you are swimming, what we'll do? We'll move you apply force in opposite direction and you move forward. Just like action reaction. Example, when object is lifted upwards to a certain height, when work done by force of gravity is negative. Suppose some body is there on down, your bag is there. When you are lifting your bag upwards by applying the force, right? So what happened is the gravitational force acts in downward direction. You are moving in the upward direction. Body is moving in the upward direction. Correct? That is comes under negative work. Means the force applied and the direction of displacement are in the opposite direction. We can say work done is negative. The second, work done by frictional force as friction and displacement is opposite to each other. Frictional force itself is that which always acts in the opposite direction to the motion. When you are walking, the force will act in opposite direction, but we are moving forward. Okay, then when brakes are applied on a moving vehicle, work done by the brakes force is negative. That is the reason vehicle will stop. So this is about the negative work. Positive work is force and displacement in same direction. Negative work, opposite direction. Now the third case you can see. Third case. What is the third case? If the body does not move from its position on the application of force, then work done is zero. First one case, right? Means does not move, displacement is zero. F into S. So if S is equal to 0, what happened? F into 0 is nothing but 0 only. So W also becomes 0. One case. So if there is no displacement on a body, then we can say the work done is 0. So example, when a person pushes a wall but fails to move the wall, then the work done by force is wall is 0. Correct? You agree or not? Right. When a body moves in the direction perpendicular to the direction, I told you. So force is acting in downward direction. Displacement is, so perpendicular is 90 degrees. Perpendicular is nothing but 90 degrees, right angle. So as I told already, W is equal to Fs cos theta is a formula when angle comes into play. So cos 90 is nothing but cos 90 degrees is 0. So total W becomes 0. So there are two possible cases where work is done is 0 is either displacement is 0 or the force and displacement are at right angle to each other. Right? Clear? So this is a clear picture about the work done. Work done. So when you see work done case, so what we learn in work done is, what we learn today is clearly about what is work, right? What is work? So work is said to be done if a body displaces in the along the direction of force, that is F into S. So work can be three types. Work can be either positive or negative or zero. So positive is when force and displacement in same direction. Whereas negative is force and displacement opposite direction. Zero is two cases. Either S is equal to 0 or force and displacement perpendicular to each other. Correct? These are the three different cases which you come across in our physics, not in day-to-day life. Day-to-day life, we cannot consider in some cases. Because we consider them in the day-to-day life, there are so many complications will come. As I told, whenever coolie is carrying the luggage, the force acting on his head or entire body is perpendicular to the direction which is moving. In such case, the work done by the coolie is 0. But still, we have to pay for him because he has done work as per the application. Right. So this is complete picture about the what is work done and what are the three types of work done as per physics. Right? Positive work, negative work, and zero work. So based on that, some questions also there here. You can solve, take the time. So mathematical expression for the work is, mathematical expression is force into distance moved. Not force by distance, not distance moved by the force, not none of this. So work is said to be done when no force is applied, when a force produces no motion, when force produces motion. When force produces motion, then only you can say work is done. Something like that you can do. So an agent is moving positive charged body towards another fixed positive charged body. The work done by the agent is definitely a positive. Right? Like that you can do simple. So work done by the body displaced in opposite direction to the applied force is negative force. A body when it moves along the circular path, the work done by the body is 0 because body will come to same point. Right? Like that you can, as per the concept point of view, easily you can answer. If any numerical points will come, you can check with your key provided for you and you can solve the many problems on work done also. Simple, based on F is equal, W is equal to F into S or F into S cos theta if an angle is given. Okay, see some problems are there. Okay, you can do many things direct, but work is measured in joule or erg, where 1 joule is equal to 10 power 7 erg. Right? So this is about the first part of the chapter, that is about work. Then comes energy, and there are various types of energies we'll come across in our day-to-day life. You know what is energy? Energy is nothing but how much capacity you have, how much ability you have to do the work. So different people will have different energies, right? So in next class, we'll discuss about what is energy, what are the various types of energies, and what is the unit of energy, where energy is applicable. Okay, everything we'll discuss in the next class in details. Then comes followed by the what is power. Again, power is also related to work done only. How fast you are doing work is the power. How fast you are doing work is called as power. See, For example, you have a lot of capacity to do work. I given you one chapter to complete. You can complete the chapters if I give 10 hours of time. That is your energy. But other person is there who can complete the same chapter in 2 hours. So what I can say is power is more. The second one, power is more. First one, energy is more. Power is nothing but how fast you are doing work. To see in your target hours or your E&D classes, when 4 questions are given, all students cannot complete all 4 questions. Okay. Some can complete 4 questions, some can complete only 2 questions. That is their power. So that power is depends on the time. Any work, how fast you are doing, that is called power, and that is also represents the energy for us, right? So we are done with the work. Work is done. I am cleaning my hands. Then next we have to go for the energy part. Next class when we meet, we discuss about the energy, types of energies, units of energy, and few examples of energies followed by the power, right? So that's all for today. So thank you very much all of you. Have a wonderful day. Thank you.